let's take a look at a couple of examples of solving problems involving joint variation. So this first one, the lateral area of a cylinder varies jointly with its radius and height. When the radius is 3 inches and height 5 inches, the cylinder's lateral area is 94.2 square inches. We want to write a variation equation and determine the area if R is 4 and H is 10. So we'll start with the area, the lateral area, varying jointly, so equals K times, with the radius and height, so K times R times H. When the radius is 3 and height is 5, so let's substitute those values in. K times 3 times 5 is equal to the area, which is 94.2. And then we'll solve for K. So 94.2 divided by 15 is 6.28. And now our variation equation is A equals 6.28 RH. So lastly, we want to determine the area if R is 4 and H is 10. So we'll substitute 4 for R and 10 for H and evaluate this expression. So 6.28 times 4 times 10, which is 251.2 square units. So a lateral area of a cylinder is actually the area around the curved surface of the cylinder, not including the bases, the circles. And so typically when we find the surface area or the lateral area, we use the formula A is equal to 2 pi r, which is the circumference of the circle of one of the bases, and then times H, which is the height. But if you then notice 2 times pi is about 2 times 3.14 or 6.28. So our constant of variation is really just 2 pi. Okay, in the next problem, the resistance of a wire varies directly with its length and inversely with the square of its diameter. So let's stop there and go ahead and write a general variation equation. So R for resistance varies directly, so K times with the length, so K times L, and inversely, so that'll be divided by the square of its diameter, D squared. Okay, next, if 100 feet of wire with a diameter of 1/100th of an inch has a resistance of 10 ohms, what is the resistance of 60 feet of the same type of wire if its diameter is 2/100th of an inch? Okay, so what we're going to do is take this in chunks. Let's start with the first part of this sentence. So we have 100 feet of wire, that's a length. The diameter, 0.01, that's a D value, and then a resistance of 10 ohms, that's an R. Let's substitute those values in, and we're going to solve for K, the constant of variation. So if we calculate this quotient, 100 divided by 0.01 squared, that's 100 divided by 0.0001, or 1 million. We're going to have 6 zeros. Okay, so 10 is equal to 1 million K, and then K is equal to 10 over 1 million, or 1 over 100,000. Next, we're going to use this value, substitute it into our general formula, and find our variation equation. So R is equal to 1 over 100,000 L divided by D squared, But that's the same thing as 1L, or just L, over 100,000 d squared, which looks a lot nicer. So lastly, we're going to take a look at the question, what is the resistance of 60 feet of the same type of wire if its diameter is 2/100 of an inch? So we substitute 60 for L and 0.02 for D and simplify. Well, this is just 60 over 40, okay, or just 1.5 ohms.